All right, this is 2007 Form B, number 6. And in this question, you're told that f is twice differentiable, which means that it's continuous too. And you're told that f of 2 is 5, f of 5 is 2, and that g of x is equal to f of x. Part A, explain why there must be a value c between 2 and 5, such that f prime of c is -1. Hopefully MVT is just like screaming at you on that one. Obviously if you find the slope of f, then you're getting f prime, right? And so the slope between f of 2 and f of 5 can be found using like y2 minus y1 over x2 minus x1, which gives you -1, which is what they're looking for. So the MVT guarantees. Part B, show that g prime of 2 is equal to g prime of 5, and then there's a second part to it. Okay, well, if we're going to figure out what g prime of 2 and g prime of 5 are, let's first figure out what g prime of x is. So you're deriving in function notation, and you have an inner function. So this f is like the outer function, so it's f prime of whatever's on the inside, multiplied by the derivative of the inside. So there's g prime of x. And then you just start plugging in. So if I plug a 2 in where I see x, I get to here, okay? And we know that f of 2 is equal to 5. So let's go ahead and replace that f of 2 with the 5. Okay, so there's g prime of 2 right there. And then same exercise with plugging a 5 in. All right, where I see x, I'm putting a 5. Okay, and you know that f of 5 is equal to 2, so we'll replace that with a 2, and then f prime of 5 times f prime of 2 equals f prime of 2 times f prime of 5, right? It doesn't matter what order you're multiplying in, so those guys are equal. And then the second part of this thing says to explain why there must be a value k between 2 and 5 such that g double prime of k is equal to 0. Well, if you derive g single prime, you get g double prime. Well, you're finding the slope when you derive, right? So like the slope of g single prime is g double prime. So if I find the slope of the endpoints of g prime of 5 and g prime of 2, well, that's me doing this right here, okay? And in the first part of this, we figured out that those guys were the same thing, right? So whatever they are, they're the same, which means when you subtract them, you get 0. And then 0 divided by 3 is 0. So yet again, MVT guarantees. Part C, it says show that if f double prime of x is equal to 0 for all x, then the graph of g does not have a point of inflection. All right, there's several ways to go about this. If f double prime is always 0, that means it's never positive and it's never negative. So then f double prime can't change sign, which is like the definition of an inflection point, so there wouldn't be any. And then, or you could say if f double prime of x is always 0, that means the graph doesn't ever have any bending at all, right? Concavity means bending. So if it's never bending, that means that it's always straight or it's always linear. And if something's always linear, then it doesn't have any concavity, so it can't change concavity, so it doesn't have any inflection points. And then part D, it says that h of x is equal to this thing in blue. And then it says, explain why there must be a value r between 2 and 5 such that h of r is equal to 0. Okay, so I replaced my x's with 2's. I know that f of 2 is equal to 5 from up there, so that's equal to 3. And then h of 5, again, just replace your x's with 5's. I know that f of 5 is 2 from the top, so that gives me -3. And then 0 is in between 3 and -3, right? Like to go from an output of -3 to an output of +3, you got to pass through everything in between there, 0 included. So that's kind of what I wrote here in a little bit of math notation. Since h of x is continuous and h of 5 is less than 0 is less than h of 2, then the IVT guarantees that you're going to get an output of 0. Okay.